This is an important question of 6.41 page exercise 6e, the 10th question, which goes on to say that the bisectors of these angles bisectors meet at the center to form a quadrilateral PQRS. Now we are supposed to prove that each of the angles of the quadrilateral PQRS is a right angle. We are supposed to prove that this is 90 degrees. Since ABCD is a parallelogram, we have opposite sides as parallel and the angles have bisectors that intersect to form the quadrilateral. That much has been given. And now we are supposed to prove that each of the angle of PQRS is 90 degrees. Now the solution. For the solution, we have clear 6 steps. The first step being AB parallel CD with transversal AD, and which can be seen here, AB parallel CD with transversal AD. That is the first. Second is external angle DPS for triangle DPS external angle for this triangle DPA is the next step, and BC parallel AD with transversal AB. Herein, since this is bisector and this is bisector, all we need is 2 and 3 and 7 and 6. And triangle DQC for the angle sum property with 1 and 2 established to arrive at Q, because as you see, PQR is part of DQC. That is the reason why we hold the larger triangle. So as I have already told you, AB parallel CD with AD transversal, we have the cointerior angles as supplementary, and therefore we have just done through the math, and finally we have arrived, since they are bisectors also, we have established that this is nothing but 90 degrees. The 2 and 3 combine to form 90 degrees. If 2 and 3 give 90, obviously the corner angle will be another 90 degree. And you can quickly see, if 2 and 3 is 90, this will be by angle sum property, this is also 90, and I have already arrived into the internal triangle being where internal angle SPQ has come out to be 90 just because these are vertically opposite angles. If these two are 90, this is 90 by angle sum property, angle P. If this is 90, I have SPQ also 90, and by linear pair I have this to be 90. Even simpler context. And similarly, I can arrive from this side with CB as the transversal. I can say that these happen to be 90, and this by angle sum will be 90, and vertically opposite it becomes 90, and so I have arrived at this 90. And the maths of this follows, how to present it in a proper format. Now that these has been addressed, now I need S and Q to be proved as 90. For that, I have picked up AD and CB with CD as the transversal, and I have arrived at the rest as you have already seen. The same explanation carries forward for this part of the problem, by which I have arrived at 1 and 2, the sum of 1 and 2 as 90 degrees. 1 and 8 as 90 degrees. The same old thing. Now picking up the DQC triangle, which I have already discussed earlier, putting angle sum property, I have PQR here, Q angle also is established 90 degrees, and the maths follows. And since PQR is part of DQC, I have PQR established as 90. Each angle of the quadrilateral PQRS, namely, have been proved to be right angles. As I have picked up DQC, I need to pick up ASB to do the needful for arriving at angle S to be 90. Just now Q has been proved to be 90. That is it.